try to get that resolved as soon as possible. Second, we reserve time during the webinar for your questions, so you can submit a question at any time by using the chat feature. And then finally, we'll be distributing copies of the slides and scheduling live demonstrations of the RightScale service following the completion of the webinar. If you're interested in either, please email us at sales@rightscale.com. And also, just a quick note, you can try out EBS on your own by signing up for one of our free developer accounts at rightscale.com. Okay, well, let's get started. I'm joined today by Michael Crandell, CEO of RightScale, and Torsten von Eichen, our CTO. The bulk of today's presentation will be Torsten taking us through the EBS technology, several use cases, and a live demonstration of using EBS within the RightScale management system. We'd be happy to address any business implications in the QA session or offline. Before turning things over to Torsten, I'd like to now introduce Michael Crandell, who will give us a brief introduction to RightScale. Michael?
Hello, everyone. This is Michael. Welcome to our first webinar here at RightScale. Wanted to just say a word for those who are new to RightScale. RightScale was really one of the earliest players in cloud computing, and our business is to provide a cloud management platform which we deliver as a software as a service web dashboard along with support. Our system enables companies to quickly create web solutions running on the Amazon cloud that are scalable, reliable, easy to manage, and affordable. And we do this by powering three areas, which you can see on the slide. The first is we offer an automated management system. Secondly, we have a library of prepackaged components covering common application requirements around database, web and application front ends, and grid frameworks. And finally, we offer support and design expertise. RightScale has over 6,000 users, and we do provide a free edition that you can test, which does include support for the EBS features we'll be talking about today. And so again, our mission is to make the power of cloud computing accessible to every business. It's been important to us to support new Amazon features like EBS immediately as they become available. And it's also important to us to make sure that as a participant in the cloud computing community, we share our views in an open way on best practices for design and deployment within the community, and hence this webinar. Before we dive into the technical side of EBS, just a quick word about the business impact and why Elastic Block Store matters. Really, in our view, EBS solves the biggest problem that EC2 has had, which really has focused around the persistent storage of data, whether that's files in a file system or data records in a database. Cloud architectures have done a great job of enabling scalability at web scale through the replication of virtual servers, distributed storage, etc., the kind of design you see on the left. But that's presented a challenge to migrating applications that were originally designed for more traditional architectures.
Michael, sorry to interrupt. There's apparently an audio difficulty here.
Oh, okay. Bear with us a minute if you can hear, and we'll be...
Well, the audio services are on, so that should be there.
Hello, everybody. I'm just going to keep going. So I've been talking about the business impact of EBS, and by providing persistent storage in a more traditional kind of configuration, like something that's close to a SAN model, EBS really allows easier migration of applications designed for more traditional architectures where storage lives separately from compute instances. So what we found is that this new enhancement that does provide storage closer to the SAN model provides a beautiful way to migrate traditional apps, including those with larger data sets, into the cloud. And so the use cases that are now enabled range from multi-server web apps that require persistent file and database storage to also include the large collection of single-server virtual appliance type server apps offered by many software vendors. And we think the SAM-like capabilities of EBS would really be the envy of any internal or traditional hosting alternative, and that's a key reason we're so excited about this new feature. So now I'd like to introduce our founder and CTO, Torsten van Eiken. Torsten was, prior to RightScale, chief architect at Citrix Online, where he designed and managed the 24/7, 365 data center operations of GoToMyPC, GoToMeeting, GoToWebinar, which are all real-time production systems running at web scale. And he's also really a pioneer in cloud computing, having started developing for EC2 from the very beginning at its launch. So with that, welcome Torsten, and tell us about EBS.
Welcome everybody. So we did a quick poll just before starting the webinar. It looks like about 2/3 of you are using, or no, almost everyone, 80-something% have used EC2, and about 1/3 or a little bit less have also played with EBS. So I hope I can also tell you some new things, and please fire off with questions in the chat if you have anything, and I'll try to weave that in. So EBS for me is the big disk array in the sky, in the cloud. You can create volumes up to 1 terabyte in size and then attach them to any instance in the same availability zone. Availability zone is, think of data center, so to any instance in the same data center. The price is around 10 cents per gigabyte, which is for the full size of the volume, not just what you use. And then there's a charge per million I/O operations. That one is a little bit more difficult to estimate, but from everything we've seen so far on standard database or so use where you're not really maxing out the performance of EBS 24/7, it kind of disappears in the noise, sort of similar to most bandwidth chargers, which are lesser than instance chargers. Great features, you can snapshot back up a volume to S3 and then later create a new volume from the snapshot, and I'll be talking more about that. So let me try to switch to a quick demo and just let's create some, whoops, I'm ahead of myself here, sorry for that. Let's go and take a look at the RightScale dashboard. I created a deployment for the demo with currently 2 servers that are running in 2 different zones. So let's look at the first server here. And so that was the standard information. And on the volumes tab, you see that I currently have a volume attached of 1 terabyte in size on dev SDJ. So now let me switch to the server here. And I'm now logged into the server and listed the disk devices, and you see the dev SDJ appearing here, and doing disk usage df, you see that it is 1 terabyte in size, and I've actually used up a little over 500, a little bit over half of the device. So let's go ahead and create another volume from scratch. Go back to the dashboard and the volumes and choose to create a new volume. And let's just call that demo 100G and put that in the same zone as the server, 100 gigabytes in size. So I'm now asking EC2 EBS to create a 100 gig volume, and I'm going to attach it, so that has happened, and I'm going to attach it to my server, and need to choose a different device, SDK, and click OK. And at this point, the attachment is going to happen. And if I switch back to the server, flipping around here a little bit, Then, whoops, that's not what I wanted. There's no file system there. Let's first look at the devices. So now the device has appeared, so it is actually attached, but there's nothing in it, right? It's a block device, completely empty. So the first thing I need to do is create a file system. We tend to use XFS. So let me create a file system on that device. That is done. And now I can mount that block device on, let's put /mnt2. And now if I do a df, I should see here I now have on SDK, I have a 100 gig volume that is mounted. And I can start copying something. I have a 10 gig file, so that will probably give some data. This is on one of the local drives, and I'll just copy that onto SDK. So we've seen performance of about 50 megabytes per second. It's sort of typical to one EBS volume from a server. And so this will take a little while. And I'll switch back here to the slides. So if there's any questions so far, please put them in the chat, and Josh will try and feed them to me. So the next feature, now that we have the volume mounted, is to look at snapshots. So a snapshot is a feature that's common in high-end disk arrays, where you can do a point-in-time snapshot of the volume and save that to a backup store and get a consistent view, thereby consistent backup of the volume. In the case of EBS, it's written to S3. It is not written to one of the regular S3 buckets. It is in a separate area, so it can only be managed through the EBS API. The nice thing is that this snapshot is incremental, so it happens, it trickles out. Snapshotting 1 terabyte takes many hours, but in the meantime, the volume is fully accessible and usable. And then to restore, you really create a new volume from a snapshot. And that's what I'm diagramming up here, where I have a server with a volume number 1, and I take a first snapshot, which ends up on S3. I take a second snapshot to S3. And then from this second snapshot, I can create 3 new volumes and mount them on 3 new servers, and thereby essentially replicate this volume number 1 to 3 additional servers. Actually, the word replication brings to my mind that one of the big limitations of EBS is you can mount a volume only on 1 single server at a time. You can unmount it, mount it somewhere else, but only 1 at a time. So using the snapshots for replication is a way you can replicate read-only data if you're preparing some DNA matching tables or so that need to be replicated to many workers. This is a way to do that. The snapshots are incremental, which means that after the first snapshot, the second snapshot only needs to save what has changed since the first one. And that makes deleting a little bit tricky and perhaps difficult to understand. So here's a little diagram where I have a volume and I take a first snapshot, which really creates a table of contents that says these are the disk blocks that are in the volume at this point in time. And so now I have 4 disk blocks below here in my little diagram. These need to be written to S3 by EBS. A while later, I create a second snapshot, which immediately creates a second table of contents. And that's how the snapshots are immediate. And this table of contents shares unmodified blocks with the prior one. So blocks 3 and 4 have not changed. So only 1 and 2 need to be written incrementally to S3. And here's snapshot 3, which has again 2 new blocks and shares 2 other blocks with snapshots 1 and 2. If I now go and delete snapshot 2, really the only thing that is freed is the table of contents and block number 2, which is missing here on the right-hand side, because block number 2 was only used by snapshot 2. Right? So with all of the sharing and incremental nature, it's very powerful because rapid successive frequent snapshots can be made at very low cost, as only the modified blocks need to be written to S3. But it makes it difficult to answer the question, how much space does a particular snapshot use? So I wanted to show the snapshots here and see a little bit how this looks like. So let's go into, sorry, I was actually in the right place. Look at the volume. This is the 1 terabyte volume that was already attached to the server. And I can create a snapshot of that. I didn't look whether the prior one, I had created a prior snapshot. I didn't look whether that one was actually completed. So let's take a look of all of the snapshots I've done of this volume. Indeed, I started one snapshot that was early this morning, and I dirtied 500 gigabytes. This was right after I copied 500 gigs onto the volume. This one is still running, so it's still at 44%. So that's going to go for a few more hours. That's a lot of data to push to S3. While I was filling up the drive, the volume, I made a number of other snapshots at sort of the about 14, 34, 68 gig marks, and those have completed. So let's just go ahead and launch one of these snapshots. So create a volume from the snapshot, and we'll create it in the other zone. So it's essentially in the other data center, and I leave the size empty, which will create the minimum. Well, the minimum and maximum size in this case is 1 terabyte. So now we've created another terabyte volume, and I can now go and attach that to the other server I have running. So down here, that was the other server, and I'll just pick another device. And so now the terabyte volume that I just created from the snapshot is being attached to my other server. And I'll now switch the screen to the other server. Just waiting. Okay, all of you now seem to be seeing that. And so what I have here is beforehand, I again looked at the 3 devices that come standard. Those are the drives in the instance itself. And now if I look, you see the dev SDL. And I should be able to mount that on, let's say, mount 3. I've created that. Okay, thinking. And here we go with, I have the terabyte volume mounted on this other instance, which if you paid attention is in a different availability zone. So think different data center from the prior one. So I've moved 1 terabyte from one data center to another effectively with a couple of clicks here. And we can, now this one had 69 gigs of data actually in it. Oops, sorry, wrong directory here. And here's my data file of 68, 69 gigs of data. Now this is, again, the restore is lazy, which means the 68 gigs have not yet actually been copied to this new EBS volume, right? It's not practical to copy 68 gigs to an EBS volume across data centers within the few seconds that it really took to attach it. So any disk block that is now referenced, that are referenced on this volume, and that is not yet on the EBS volume itself, will be pulled in from S3. So it's sort of lazy as the application or whatever is running touches blocks, they will be pulled in from S3. And at the same time, in the background, everything else gets that is not being accessed is also being pulled in. So it really makes for a very powerful way to manage the volumes. In all of this, one has to be a little bit careful about being safe. One thing that I didn't do here in the demo is to freeze the file system, and if you're running a database, you really should be freezing the database while creating a snapshot so that the snapshot ends up with consistent state of the disk. Also, when moving volumes, you can unmount a volume from one instance, mount it to a volume to another instance, in the same data center, same availability zone. That's fragile. Unmounting, you need to make sure you've synced everything to the volume. And on mounting, you better have this scripted and automated, because one little mistake using the wrong file system type, anything can very easily destroy the entire volume. So that's again where snapshots come in. So whenever you unmount a volume, always create a snapshot. This way, later on, if something happens, you always can go back to the snapshot and try again. And really, we tend to think of creating always a fresh volume from the snapshot and pretty much discarding the old volumes. You can optimize in some cases, but that's also what allows you to move volumes from one availability zone to another. So I'm going to switch gears here and talk a little bit about the use cases. Certainly the most interesting one is running a database. And now with EBS, here's the way we're preparing this. We have all of this running, but it's not yet in release shape. So it's going to become available, the server templates and our manager for MySQL in a few weeks. This shows two app servers talking to MySQL master server in one availability zone where the database store is really on EBS. In order to create a slave, and typically we put that into a separate availability zone, the way we proceed is to create a snapshot to S3 and then create a second volume for the slave in EBS in the other availability zone. At that point we can attach and mount the volume. We have the initial data, and then we can start replicating the standard MySQL replication. So that's really the big difference to what we have today, where we store the database on the local drives, is that creating a slave for large databases, think tens of gigabytes or even hundreds of gigabytes, is now doable in a reasonable amount of time. Whereas before, copying that much data over was often painful. In terms of failover, the way things look is, again, I have here 3 app servers talking to the master with its EBS volume and frequent snapshots being made to S3 in order to always have a current backup. Should the master fail, the first thing is to promote the slave to master and then fail over the app servers to the new master. The failover currently is done, what we recommend and do is using dynamic DNS failover. We're looking at using MySQL proxy, but that's still a little ways out to really stabilize. So now that this machine has become the master, we need to take a snapshot and then again creating another fresh volume from the snapshot, so we can launch a fresh slave and be again at square one with a replicated database setup. The nice thing here is it's always rolling forward. So you never have the tension of wanting to repair the broken database server in order to be able to replicate again and have 2 servers up. Instead, you can forget about it in the heat of the moment, and then the next day you may want to do some forensics so you can avoid problems in the future if it was a software glitch or software issue. But at the moment, you always roll forward. So just in multiple zones, just in interest of time, I won't go into too much detail, but we definitely recommend running the slave in a different availability zone from the master so that you have redundancy there. The one catch is that when you fail over, if the database master instance, say, failed, then suddenly the app servers would be talking to the database across availability zones. So at that point, you either need to fail back to a fresh server in the original zone, or slowly move the app servers into the new zone so that you avoid the latency and cross-zone communication charges. The other use case that we see a lot of interest is software companies selling their software as a service, sort of a hosted version, by essentially providing EC2 servers with attached EBS volumes to their customers. So when a customer buys a software, what they're really getting is an EC2 server with an attached EBS volume with their data, and now that's a hosted offering that they can rent from the vendor. And where EBS comes in is that from a reliability point of view, using the snapshots, there's really a good way to persist the data such that even a total failure of the instance and the EBS volume doesn't cause a lot of loss of data. Obviously, it's back to the last snapshot, but that can be only a few minutes away. And as the vendor signs up more customers, it's basically step and repeat, clone the server with the attached volume and ready it for the next customer. And there's some flexibility in terms of horsepower of the server as well as size of the volume. What we provide here is a notion of a master account and sub-account, so that through the RightScale dashboard, the vendor can entitle, manage customers, support them, access their server, and aggregate the different billing items and bill out the various usages. So kind of getting towards the end here of the webinar, and we'll have plenty of time left for Q&A. In my mind, the clouds are really starting to surpass traditional hosting. When I look at the flexibility with server sizes of volumes, with snapshots, replicating them through snapshots across data centers, having IP addresses I can reassign across data centers to different servers, the multiple failure zones, and Amazon has pretty clearly hinted that they will be offering multiple geographies at some point in the not too distant future. And what's really nice about the cloud is that it's built to enable automation. So the things we're doing in RightScale to automate and simplify the processes to launch servers and perform operations on them, it's really enabled by the cloud, and that makes it a lot more powerful and really more than I ever had when I used traditional hosting, even paying quite a lot of money. So just to talk a little bit about the support for EBS in RightScale. First of all, in the dashboard, all EBS functions are supported, and that's part of the free developer edition. So there's volume snapshots, you can give them nicknames, you can see history, you can see audit entries, and maybe we have just a minute here to take a quick look. So if I go back to the volume here, I can see the, whoops, that was the new one. Sorry for that. Go back to the original volume. And so I can see all of the snapshots I did of this terabyte volume. And I can also see a bit of the lineage, which is that I took this volume, I created 3 snapshots, and then I took one of the snapshots and created this other volume that was at the 14 gigabytes mark. And then I took 2 more snapshots, and just before in the demo I took the 68 gigabyte sized snapshot and launched another volume. This is what I demoed before. So you really get the history and the tracking of what happened, and you can follow that. And if I go back to the server, I can also see in the audit entries, and you'll see some of the dirty laundry of me trying it out last night, where I'm attaching and detaching the volumes. All of this creates audit entries, and you can see who the guilty is. So keeping track of all of that is part of the RightScale dashboard. We support then auto-mounting volumes at boot time. So when you define a server, whenever you launch it, automatically the volume gets attached. I showed the lineage, and what's coming up is full support for EBS in our server templates, including the manager for MySQL. And also something we found quite useful when handing out virtual appliance servers is have a way to create snapshots without having the credentials embedded in the server itself, so that whoever has access or log into the server can't get at the master account credentials. So that's pretty much the roundup. And just before we open Q&A, I wrote quite a bit about EBS on the blog. You can also sign up for a free developer account. Just a little warning here, don't get a trial account. The trial accounts are limited for technical reasons and don't have access for EBS. So you will have to have an Amazon account and hand your credit card to Amazon. So you'll be paying for instance time and ECS usages. But to play around with a couple of hours really amounts to almost nothing. There's a lot of tutorials with EBS on our wiki, and obviously we'd love to hear from you. So before I take Q&A, thanks for listening. I hope the audio worked. And Josh, how are we doing with questions?
Great. Well, we have lots coming in, so thanks, Torsten. And thank you all for a flurry of questions here. We'll take off as many as we possibly can and address them now. What we'll probably do, given the number of questions, is we'll recirculate to the group an FAQ. There's been a lot of recurring themes here, and we'll get that out to the list. And also, before we get to the Q&A, there were several questions on the availability of this post the webinar. Yes, the slides and hopefully the audio will be available for download on our site. And again, we'll be distributing that out to the list as soon as possible. So first,
what happens when you bring down the server? Do you need to remount the server? Does that need to be part of the scripts on the server templates? So when you bring down the server, yes, the volume stays. And when you boot the server again, at the EBS level, you need to explicitly mount the volume. We have a feature where you can say automatically mount it on boot. And now I'm blanking out. I think we need a write script in order to explicitly mount the volume, because we don't know necessarily on which mount point. The slide shows multiple servers connecting to EBS, so that's definitely not possible. I'm not sure. I must have had a confusing slide. You can have multiple EBS volumes on a server, and I showed that in the demo actually. Again, can two EC2 instances share the same EBS volume? Sorry, no, for distributed file system, this is not yet the solution. For snapshot cron jobs, so that's an interesting topic. Even though there's a snapshot button on the dashboard, that's not what you should be using while the server is running and cranking away. It's very handy if the volume is sitting there, has been unmounted, you want to create a snapshot, or if the server is quiescent. If you have a database running and being active, you really need to run a script on the database server itself that goes through freezing the database, or getting a read lock on all tables in the case of MySQL, freezing the file system, and taking the snapshot, and then unfreezing everything. That takes a couple of seconds, and we're still testing to see what really the hiccup is at the database level, but that's the way to get a really consistent, clean snapshot. And the reason we use XFS is multiple. One, the most important one is that there's an XFS freeze command, so it has the notion built into the file system of freezing the file system so you can take a clean snapshot. And also it formats very fast, so when you create a volume, you're not waiting a long time for the formatting to occur. Everything that you do directly with the API, so there's a question whether things you create outside of RightScale appear on the dashboard. The answer is yes. We poll EBS and EC2 and they show up. Of course, they have no name. So if you want to be able to remember later on what they were, you probably want to give them a quick nickname. RAID arrays with EBS. So that's another interesting question. Amazon has been pretty careful in talking about the reliability of EBS, and I know that was a hotly debated internal discussion. And if you read the statement carefully, it says that EBS volumes are replicated. They are on multiple servers. That's the term they use. So a single hardware component failure, server or disk, will not bring an EBS volume down. And really, the recommendation is that you don't do things like mirroring two EBS volumes to each other. That just increases network traffic and probably doesn't give you much additional resiliency. For example, if whole racks went out or the whole availability had a power failure, well, your two mirrors would be in the same zone, so that would take it out anyway. So really focus there on the snapshots. Striping multiple EBS volumes to get higher performance clearly has value. We see, so the speed of light, it's indicated that 1 gigabit is really the connection, max connection you have to EBS from any particular instance. We see about half of that with one volume. So using 2, 3 striped volumes can give you higher throughput. There's some trade-off with increased complexity and dealing with everything. But if you're really at that edge, then that can give it a little bit of extra. Another question is, does the lineage feature only work for volume snapshots launched via the RightScale dashboard? I have to admit I'm blanking on that one. I shouldn't have picked that question. I believe EBS does say which volume a snapshot came from, but I'm not sure we can do all of the connections. So I believe it's only if you do it from the dashboard. How often do we recommend snapshotting? And we're still, we've done a lot of experiments on the alpha, but now that it's live, we still need to keep going. My sense is every few minutes, every 5 minutes, every 2 minutes. And my biggest concern is whether you need to freeze the file system and the database and what hiccup that entails. And really, to do that, the snapshot is an API call to the EC2 front end. We've seen it respond quite immediately, but that's still something that we need to do more testing to check. You don't want to have too many hiccups to the database if it's running at a high transaction rate or if the response time is critical. But on the order of minutes, if you look at the 1 terabyte volume where I did a snapshot, that took many hours. I'm expecting that once the first snapshot completes successive snapshots, the snapshot itself should return immediately, and then only the modified data gets pushed, which, unless I'm doing something crazy again, should be just a few minutes of pushing some 100 megabytes or so to S3. Do you need to take the MySQL master down when you take a snapshot? Absolutely not. So you take a lock, you lock all tables. I mean, you can certainly do just a snapshot and cross your fingers and rely that the database can recover. It's equivalent to pulling the plug on the disk and then later plugging it back in. But no, you don't need to take the database down. The latency. So someone is asking about using multiple availability zones and what is the latency hit. I'm not sure that at the current time you see that much of a latency hit. The reason I'm saying that is before Amazon introduced availability zones, they had pretty much, probably not the same, but they had servers in the different availability zones. You could, as a user, you just couldn't tell. And I don't think we really could tell how big a latency there was, but I'm expecting that you'll see more variability in the latency just from other traffic, from other users. Obviously, at some point, it needs to go through some routers, and if they're physically disjoint, there will be some bandwidth bottlenecks. So the other thing maybe I can go back to the slide that I had here. What I showed here is running 2 load balancers, one in each zone, hitting 2 app servers in the same zone as the master. So the traffic that goes through load balancer 1, everything stays within zone 1. Traffic that comes in to the second load balancer in the other zone needs to cross zones to hit the app servers. In terms of latency, it's a wash. It doesn't matter because you already went through the internet to come into the load balancer in the first place. So the little extra really is not noticeable. In terms of bandwidth, the internet bandwidth is, I forget, depending on which tier, 15 cents or thereabouts per gigabyte. And cross zone is 1 cent per gigabyte. So you're adding, if half of the traffic comes in the load balancer 2, you are adding, 5% of cost in order to have 2 zones. That's really, of bandwidth cost, sorry. Typically, for most people, that's in the noise. If now you run an application server in zone 2, then now the application server goes across zones to the database. But the volume of traffic there can be orders of magnitude larger than the internet request, in the case of a web server, the HTTP request coming in. Right, the communication, it can be fetching a lot of data from the database and then just sending a pretty brief HTML page back to the browser. So here you have really a bit risk exposure to larger costs for this interzone traffic. And that's application dependent. Something I would like to move towards is to shift a small amount of traffic to this third app server so that it's warm but is not doing a lot of work and is not, doesn't really consume a lot of interzone bandwidth. So someone is asking about 50 megabytes per second, and I've seen that for both reads and writes, and we can take a quick look here. This is the demo server. Go into the monitoring tab, and I think SDJ was the, actually I have here already the saved graphs. So SDJ is the terabyte volume, and this was last night when I threw the 500 gigs of data of junk data onto that disk. And you see here that was round about, I guess average is around about 45 megabytes per second being written over, that's an hour and a half to the volume. And you see here below in the CPU graph, the red is I/O wait, so that's CPU 0 not having anything other than to wait for the data to go out. And you also see that on the network port, there is no traffic. So clearly this disk I/O goes through a different network interface than the one I'm seeing as Ethernet 0 here. How are we doing, Josh, here? How much load does snapshotting put on the machine? That's a very good comment. That's one of the huge benefits of EBS. There's clearly you get the large size, you get a lot of benefits there, but in performance. But in addition, you get some other device that shuffles data for you. So when a snapshot occurs, it goes straight from EBS to S3 and doesn't directly affect the instance. So no data goes through the instance. Obviously, the data has to come off the platters somewhere, and so there's some disk utilization, and so you should expect to see some reduced performance. We haven't really been able to tell, and I don't want to make any comments at this point. Just on the replication for MySQL, I probably was a little bit confusing in the old setup. So if you have the database on the local drives, then in order to set up a slave, you need to make an initial copy of all of that data. So if you now have 100 gigabytes on the local drive, it will take a long time to get it to a second server onto the local drive. And that's where EBS comes in again, is by putting that data onto an EBS volume, using the snapshot and creating the other volume from the snapshot. It's a matter of minutes, especially if you have current, if you've been keeping up with making frequent snapshots on the master prior to doing this. So that's where really within minutes you can get a slave up and running. Some confusion about many nodes accessing the MySQL database. Now the MySQL, and will it create 100 copies, so many copies of the database? No, it will not. That's on the server, and you have many app servers accessing MySQL over the network. What features are we offering in RightScale that aren't available in the free applications like Elasticfox or the Amazon scripts? It really gets into the integration with our server templates in the whole MySQL setup with all those things, adding names, keeping track of the history, being able to see audit entries of who mounted what, where, when. After 3 months, when you've gone through a dozen volumes, when you have 50 snapshots of those volumes sitting there, and you're trying to figure out which is which, and you would like to roll back, you would like to go back to something, or even just clean out, and want to make sure you're not cleaning out the volume that has valuable data on them. That's really where a lot of the pieces where RightScale comes in, and being able to build your own automation around the volumes. Question about, is it necessary to create regular snapshots for data protection? Absolutely. An EBS volume sits on, again, is replicated within a zone. There could be a fire. That could be the end of the hard drives where your data is on. So creating a snapshot pushes it to S3. S3 stores everything replicated in multiple availability zones, such that a fire or power outage should not affect all copies at the same time. So definitely very important. Also, anything you destroy, any mishap you have on that volume, instance crashing, corrupting the file system, anything like that, you want to have current snapshots. So it's really important to do that. And backups are important. This is a form of backup. Question on what we've done in terms of performance measurements. We haven't done Bunny++. There is a message in the last day or two on the forum, actually. Someone was reporting, and that pretty much jives with what you've just been seeing here on the screen, with one volume doing random I/O, sequential I/O at somewhere around 30 to 50 megabytes per second. Random I/O, of course, is slower, and their EBS really is a lot better than the local drives, even all 4 drive stripes on an extra large. And they did striping across 4 EBS volumes and pretty much maxed out the gigabit network link to EBS. So that's, and as far as we can tell, those 120 megabytes per second, which is what you get on the gigabit, is speed of light. Are we updating the MySQL management scripts to handle backup scenarios with freezing for snapshots? Absolutely, that's what we're working on right now. Solaris AMIs and using EBS with a ZFS file system, we haven't been able to get our hands on that ourselves. I have seen, I'm pretty sure folks at Sun are keeping up with EBS, and I'm pretty sure that will be available real soon. but that's just from some of the things I've seen. I can't speak for them. What are the common mounting mistakes that people make? I alluded to the fact that if you do a mount, well, when you do a mount, if there's some recovery that needs to happen on the file system, that can already change data. Sometimes that's irreversible. If you try to mount an XFS file system as an ext2 file system because you mistype something, that can pretty much corrupt everything. If you partition the drive and then you try to mount the whole thing as if it were one, not partitioned or vice versa, all of these things very quickly you end up with total garbage and almost irrecoverable data. Or if there is something that needs to be recovered, you run XFS recover, or I think that's what it's called, and it fails. And you want to try, and then you read the manual and see there's this other option I want to try. Well, now things have already been changed, and you may be further into the land of irrecoverability. So that's really where always create a snapshot, and I think that's probably one of the options we should be adding to the dashboard, that as soon any volume that gets unmounted automatically has a volume created. Do snapshots cost? Yes, they do. You're storing data on S3 and you'll be charged for the data you're storing on S3, and you'll be charged for the data you're transferring to S3. Those charges are the standard S3 charges, 15 cents per gig per month, and whatever, 10 cents, 15 cents per 1,000 puts. I think the transfer charges are pretty much in the noise unless you're doing something very extreme, because it is relatively large blocks that get transferred. But of course, currently, and that's one of the criticisms I have for EC2 folks, you can't tell how big a snapshot is. So it's kind of hard to figure out, what am I paying? Why am I paying? What can I delete in order to stop paying this much? And so that's a little bit now. There'll be an update sometime soon that will give us more information. If a snapshot, another question, takes several hours to do, can you create a new volume with it before the snapshot is complete? And the answer is no. So you can start another snapshot while the prior one is still cranking, but you can't create a volume from an incomplete snapshot. And if you think about it, if you created a volume and you were to access a block that has not yet been copied to S3, then your new volume would have to somehow retrieve that block on demand from the original EBS volume. I guess that can be done, but that starts getting pretty hairy. So for this reason, it's important to keep current, right? If you have a snapshot you did 5 minutes ago, then taking a snapshot now and creating a new volume from this will be very fast. If the last snapshot dates back eons ago, then doing a snapshot now might take a long time. I think probably the last question here, as we're nearing the end of the hour. And so someone is asking about what the scripts can do and what we'd have to do ourselves manually. So in the case of the manager for MySQL, all of the regular snapshots, first installing MySQL, creating the initial volume, setting up the data, setting up MySQL are scripts that we will be providing. All of the regular backups on the master, on the slave, so creating the snapshots is again something we will be providing. Then it's a one button press to launch a new slave that then gets a snapshot and a new volume from the master and initializes and completely comes up as a running slave that is now in replication. So it's really automating all of the different tasks around managing a replicated MySQL setup.
Torsten, we do have about 5 more minutes. There are a couple more questions that came in. If
okay, I can keep going here. Can snapshots be cloned if I need to mount read-write on many instances? Yes, but of course they won't be sharing any of the updates, right? So you can set up data on a volume, take a snapshot, mount it on 10, I guess 100 other instances, and those are read-write mounts. It's just if instance number 99 writes something to its EBS volume that's its own private affair, the other instances will not see those changes, right? Each one has its own private copy now in its own EBS volume. So if another question about snapshots and about the storage. If EBS is frequently changing, it seems as though the space used by frequent incrementals could be large. Will they grow indefinitely unless explicitly deleted? Yes, they will. Right? Every time you take a snapshot, any data that has been modified needs to be written to S3. If you keep going, you will keep adding data and you will keep paying for the additional data stored in S3. And if you look at the forums, this will end currently when you reach 500 snapshots, because that's a limit per account that Amazon currently imposes. And contact them if you need more for some reason. So you do definitely want to have some rolling management of snapshots and keep the last 5 or last 10 or some variant thereof. This way you do trim the amount of data, and eventually you should reach a steady state. And we'll be offering support in that in RightScale to manage that and delete the snapshots.
Okay, well, thanks, Torsten. Unfortunately, we're out of time, but do appreciate all the questions that came in. So a couple closing remarks. Again, we'll make all this information available on our website and get that out to the email list. Do encourage you, if you'd like a live demonstration of anything you saw today of the RightScale management system, please email us at sales@rightscale.com. And please do check out Torsten's blog at rightscale.com when you get a chance. And again, thank you for joining. Hope you found this.
Please be free to post a comment on my blog if you have questions that I didn't cover. I'd love to see your questions on the blog, and I'll do my best to respond. So I don't know what I signed up for, but here we go.
Great. Thanks again. Have a great day, everyone.
Thank you for listening.